Okay, today we're going to be solving equations with variables on both sides of the equal sign. So the first thing I'm going to do is draw this line to separate it into the two sides. I have a left side of the equal sign and a right side of the equal sign. And I notice that on the left side I have a term that has a variable d, and also on the right side I have a term with a variable d. They're kind of like terms, but they're not because they're on two separate sides of the equal sign. So what I want to do is eliminate one of the variable terms. So I choose to eliminate the 4d because it's smaller than the 5d. I can eliminate the 5 if I want it, but I rather eliminate the 4d because it's smaller and it keeps it positive. So how do I eliminate this positive 4d? I'm going to subtract 4d from the positive 4d, and this will cancel out. But now, once I do that, whatever I do to one side, I have to do the same exact thing to the other side. So I'm going to subtract 4d from the 5d on the right side. So now my equation on the left, I'm going to be left with an 8 equals 5d minus 4d is 1d. And of course, we want to have the d by itself. So what I'm going to do is I'm going to divide by 1 on both sides. Divide 1 so that the 1 will cancel out and give us just d by itself. And whatever I do to one side, I do to the other side. 8 divided by 1 is 8. So there is my answer right there. And whenever I get an answer, I can always check to see if it works. Basically, take the answer you get and substitute it in to see if it's true. So let's see. Okay, so I substituted the 8 in for the d's and see if it comes out. Does the left side equal the right side? So 4 times 8 is 32. 32 plus 8 is 40. So on the left side we get 40. What about the right side? Well, 5 times 8 is 40. So we get 40 equals 40, which lets us know that the answer that we got of 8 equals d is correct. Okay, so here's our second example. We have 6x minus 2 equals x plus 13. So first thing I'm going to do is go ahead and separate this to two sides. And I take a notice that I do have two terms. I have a term with an x on the left and a term with an x on the right. So I have a 6x and an x. Okay, so what I want to do is decide to cancel out one of them. So like I did last time, I'm going to cancel out the one that's smaller. So this x over here, I'm going to subtract an x. Subtract x from x, that cancels out. But whatever I do to one side, I do to the other side. So I'm going to subtract the x from the 6x, leaving us with 6x minus x will give us 5x left over. So 5x, bring down the minus 2, the equal sign, and the 13. So now what I want to do is, it's like a two-step equation. Now I want to start isolating for the x. I want to isolate for the variable x. So to do that, I need to eliminate the constant first, the minus 2. So how do I eliminate minus 2? I'm going to add 2. So I'm going to add 2. Minus 2 plus 2 cancels out. But again, whatever I do to one side, I do to the other side. So I'm going to add 2 to this 13 over here, giving me a 15 on the left, on the right, equals, and bring down the 5x. So now this is 5x. We're still trying to isolate this variable right here. So we have a 5 times the x equals 15. And so what do? The opposite of multiplying by 5 is to divide by 5. So dividing by 5 over here means I'm going to divide by 5 on the other side as well. So I get x equals 15 divided by 5 is 3. So that's that. Okay, example number 3. Once again, I draw my line to separate my equation to a left side and a right side, and take a notice that I do have a variable term on the left, that is 6n, and a variable term on the right, which is 4n. And I want to eliminate one of them. So which one am I going to eliminate? I'll eliminate the 4n. So to eliminate it, it's a positive 4n. I will subtract 4n from both sides, because whatever I do to one side, I have to do to the other. So I'm going to take 4n away from here. So 6n minus 4n is 2n plus 1 equals, make sure we keep that minus sign or the subtraction sign with the 5. It makes it like a minus 5 right there, or a negative 5. So here, now I'm at the point where I have a two-step equation where I want to isolate the variable. So I want to isolate this variable n, and I have this plus 1 and a 2. So in the first step in isolating this variable is to cancel the constant. So we're going to cancel this plus 1. So the opposite of adding 1 is to subtract 1. So if I subtract 1 from the left, it cancels out, but whatever I do to one side, I do to the other. I've seen many mistakes here. You got to make sure you remember how to subtract a negative 5 and a negative and minus 1. This is a negative 5 minus a positive 1. So what's going to happen is we're going to add the opposite. So that means I'm adding a negative 1. Okay, so that's negative 5 plus a negative 1 makes it a negative 6. And so I get 2n equals negative 6. Some of you guys are like, hold up, do that again. Okay, so for those of you guys who wanted me to do that again, negative 5 take away 1. This problem right here, if I put this into my scoreboard, I have two negative numbers right here. We take the signs, right? So I have a 5 over here and the 1 over here on the same side. We add them together, and the sign with the most points wins. So the negatives win. So that's why we ended up with a negative 6 over here. Another way is looking at it as the subtraction rule itself. Subtraction means to add the opposite. We add a negative 1, just like I did over here, and that's how I ended up with negative 6. Okay, so those are a couple ways of how you should see it. Now back to the problem. Okay, so we still notice that the n is not isolated yet because it still has this 2 being multiplied to it. So to get the n by itself, we're going to divide by 2. So that gives me my n, and whatever I do to one side, I do to the other. So negative 6 divided by a positive 2 gives me a negative 3. All right. Last example, and this example has fractions, which scares plenty of students. So I'm going to show you a technique that I use called clearing the fraction. And in order to clear the fraction, the first thing we're going to do is find the LCD, which is the lowest common denominator. It's basically the multiple, the smallest multiple, not the this is where students get confused. For example, over here, if we wanted to find the lowest common multiple between 4 and 12, a lot of students would say 4. It's the lowest common multiple. But no, that would be the greatest common factor. The lowest common multiple refers to the multiples of each number, meaning their family. Like if I go 4, 8, 12, 16, 20, and so on, the multiples of 12 are 12, 24, 36, 48, and so on. So the least common multiple, or least common denominator, if we're talking about the bottom number of fraction, will be the smallest number that they have in common, which we would see here would be 12. Okay? So make sure you know the difference between the greatest common factor and the least common denominator. The least common denominator deals with the multiples. So like this. Okay? So now back to our problem over here, because that will come in later. But back to this problem. So here we have a denominator of 5 and a denominator of 5. Makes it really easy. The common denominator obviously is 5. So what am I going to do with that information? Okay, so what I'm going to do is multiply every term by the LCD of 5. It's kind of like the distributive property. I'm going to take this 5 and multiply it times everything. I'm going to multiply it times this 3/4. I'm going to multiply it times this 15. I'm going to multiply it times this 6 over 5x. And I'm going to multiply it times this 12. So it's going to make it look real long. So bear with me. 5 times 3/5 x minus 5 times 15 equals 5 times 6 over 5x plus 5 times 12. Okay, see, so I multiplied it times every term. Okay, so I have this 5 right here being multiplied times every term. Okay, so whenever I multiply a fraction, like 3/5 times a whole number, we put that whole number over 1. Doing this allows me to cross cancel. So 5 and the 5 cross cancel to become 1. So this really is multiplying 1 times 3. Instead of 5 times 3/5, it's 1 times 3, giving me 3x. Okay, minus 5 times 15, which is 75, equals, again, we have a fraction, so I'm going to put that over 1. So that allows me to cross cancel. 5 goes into 5 one time. 5 goes into 5 one time. So 1 times 6 is just 6x plus 5 times 12, which is 60. So look at here. We end up with no fractions. So we still deal with it just like it's a equation with variables on both sides, but without the fractions now. That's my little tip, my trick. So now I still notice I have a 3x on the left and a 6x on the right, and I want to eliminate one of the x terms. So I'm going to eliminate the 3x. So take away 3x over here, that cancels out. But whatever I do to one side, I do the same thing to the other side. So I'm going to subtract 3x from this 6x. So this leaves me with minus 75 on the left. 6x minus 3x is 3x. Bring down the plus 60. So now I need to start isolating for this variable right here. I want to isolate for the 3x. So, or actually I want to isolate the x. There you go. Let me correct myself. I'm isolating the variable x. So I want to get rid of the 60 and the 3. So I have a plus 60. So I'm going to cancel the constant first. So I'm going to subtract 60 right here. But whatever I do to one side, I do to the other side. And once again, I have a negative 75 minus 60, so they're both negative. So I end up adding the two negatives and becoming 135 equals 3x. And our last step in isolating this x, because remember we're trying to get x by itself, it's being multiplied by 3. I'm going to divide by 3 to get my x by itself. And whatever I do to one side, I do to the other. And 3 goes into negative 135. How many times? 45 times. And a negative divided by a positive is negative. So I get negative 45 as my answer.